Before, we've talked about everything being made of atoms, everything being made of molecules. Atoms make up everything. The heat energy is how fast those atoms are moving. Even this solid table is in motion right now. It's moving. Now, as we add heat energy, these molecules move faster, and if we remove heat energy away, they move slower. And heat is a type of energy. So if you think on the dance floor when there's very low energy and some people are just very slow dancing, but then you add a whole lot of energy to it, next thing you know, they're jitterbugged, they're moving everything around, and need a whole lot of more space, and everything expands or moves out. So to show you that, I have this example. In different metals transfer heat at a different rate, as well as different metals will expand and contract differently. So here I have this aluminum rod on here, and we can see where it's at. It's on the 0 mark. I'm going to adjust it. We're on the 0 mark right now. Let's see what happens when we add heat energy to this metal. Here we can see we've added heat energy to this rod, so the molecules are moving much, much faster. As they move faster, they spread out. So as these molecules have spread out, it's pushed against the rod and we can see that it's moved a significant amount. So as we add heat energy, those molecules start moving faster. So if we heat metal up, metal will expand. Also, if we heat a fluid up, a fluid will also expand. This is why water heaters a lot of times will have an expansion tank, allowing space for that water to expand to so it doesn't actually blow up or break or bust. So we heat metal, it expands. We heat water, it also expands. When we heat a gas, it'll expand or increase pressure. It would prefer to just simply expand, but if we have it in an enclosed space and we heat it up, it will increase the pressure. The molecules are actually bouncing off the sides much harder, and that's why our pressure goes up. So in this case, we're going to not put it in a sealed container. We're going to think about it in an open space. So now we're going to talk about convection. Now that we understand that, we need to think of convection. And convection is the transfer of heat through a fluid by motion. Transferring heat through a fluid by motion. So let's continue on this. Hang with me. We're going to do a little experiment here. So you've heard people say that heat rises. It's really not true. Heat can move in any direction, but because of convection, warm air rises because warm air is less dense. It's a very important thing we need to think of. When we're going to be working with gas furnaces later on, we heat up that fuel, and the fuel mixture is going to travel up and out via natural convection because it's less dense. It's the heavier, denser air pushing down that forces the lighter, less dense air up. So when you talk about heat rises, it's not true. We have to specifically add in warm air rises because it's less dense. Warm water rises because it's less dense. It's very, very important we think about this. Also, we're going to be dealing with base heaters. Base heaters go along the base of the floor. What that heater does is heat up the air by conduction. The air is touching the heater. Now the heater heats up the air molecules spread out. There's more heat energy. So they spread out. They become less dense or lighter. The cooler air coming down pushes that less dense, lighter air up. And you actually have heat moving around the room because of convection. Very, very important term. So here we just have us a glass tube. It's sealed all the way except for one hole at the very, very top. We have some yellow food coloring. We're just going to drop a little yellow food coloring right in the very top and let's see what happens. 2 drops should do it. And if you see that food coloring goes equally pretty much on both sides. It's pretty well level. And because the food coloring is more dense or heavier, it starts to flow down and it's going to start coloring this water. And I probably don't have it perfectly level because you notice there's a little bit more flowing on this side than the other side, but it's all right. Let's take now and try our experiment. What I'm going to do is put this candle right underneath one side of this glass tubing. And let's see what changes. Now if you notice, we still have a little bit of a gap here where the food coloring hasn't met, but we're now starting to flow the opposite direction. The little bit of food coloring I've left over here on the side is now flowing only in this one direction, And over here at the bottom, we can still see a little bit of movement happening. But since it's all yellow, it's hard to see any change. So let's add now some different food coloring. Let's add a little bit of blue food coloring, and let's see what changes. Just put one drop, let's see what happens. Now we can see that food coloring moves instantly in only one direction. We've mixed blue and yellow, so now we end up with green color. We can see it specifically flowing only one direction, and we can see how it's moving as it's falling off the filler neck. Cooler, heavier, more dense fluid falls on the right, and as we're heating it up on the left, the warmer, less dense fluid is lighter, more buoyant, and it starts traveling up. You can even see how the food coloring changes its density as it starts to travel up on that left side. So we put a little candle inside of our box. I'm going to use a little smoke generator over here on this side, and we can see that the smoke just travels straight up and away. Nothing exciting at all. But let's put our smoke generator over here on this side and see what happens. And when we put it on this side, we can see that that smoke is pulled inside through this tube. That's because the air on this side is cooler or more dense. That more dense air is heavier, so it drafts down. We heat the air up, it expands, it separates, and it becomes less dense or lighter, and it's traveling up. The cooler, denser air is pushing that less dense, light air up. So we'll try that one more time. Let's look at this a little different. Right now this glass is completely full of vapor. I'm going to add in a little bit of alcohol. And what's happened is the alcohol was more dense than the vapor, than the air. So it went to the bottom. It actually pushed the air up. Now let's try something else. We'll try a little bit of olive oil. As we add olive oil actually pushes the alcohol up because it's more dense. The alcohol is less dense, so it's lighter, so it rises up. Now we look at the air. The air is even less dense than the alcohol, so the alcohol pushed the air up. This is density. Now we're also going to try another form. We're going to put some water in here. Now because of the weight of the water when I put it in, it caused a little bit of mixture action. But if we give it a little bit, it's going to settle out. And as we see, the density is happening already right now. The water was more dense or heavier, so it sunk to the bottom. That pushed up the olive oil. The olive oil pushed up on the alcohol, and the alcohol pushed up on the vapor. This is how essentially air works. As we heat air up, it becomes less dense. The heavier air, the more dense air is going to come down. The cooler air comes down. The cooler air pushing down is what pushes the less dense or lighter air up. So when you have a fire and you feel above the fire and you feel all that heat, that is heat transfer by convection, the movement through fluids, and air is a fluid, and it's because of density. One final thought on this. You ask people, is the glass half empty or half full? Well, if you ask an HVAC person, they will always say the glass is 100% full, 50% liquid and 50% vapor. Another thing about convection is as we sit here in the room, our body is warmer than the air temperature. So it's actually transferring heat to the air by conduction because the air is touching our body. Once that air heats up, it expands, becomes less dense. The molecules are moving faster, it spreads out. The heavier air pushes down, that causes the lighter air to move up. So even around our bodies right now, we're having natural convection as a cooling method. A lot of motors rely on natural convection for cooling as well. As the heat around that motor gets warm, the density changes, the heat will rise up because it's less dense, the cooler air pushes down. When I have the torch lit up, I could feel the heat because of natural convection. The air was lighter, less dense, it was rising up because the heavy air is pushing it down. The movement of heat through fluids, and air is a fluid. Very important, we're going to talk about this. We get the gas furnaces, as well as it deals with everything about us HVAC. One of the things my grandmother loved was windmills and hot air balloons. Let's look at a hot air balloon, for example. We have the big burner in the center, and what that's doing is heating up the air, causing the air to expand and become less dense or lighter. So the molecules are very well spread apart inside of this balloon. But if we think also about the air is going to be cooler than that or heavier. So as the air is pushing down, it literally is causing the balloon to lift up because it's heavier. So the balloon naturally drafts up. Another reason that you see balloons in the morning is because of that density. If the air is already hot, then you have to have way more heat inside that balloon to provide the lift. So by having it in the cool mornings, the air is already more dense. The difference in density will allow that balloon to rise. So it's really like a pressure difference or a weight difference, if you will. The other reason they fly in the morning is because of wind, and we'll talk about that separately.